away from our planet. And so, just to give that number some perspective, it's about 0.41 lunar distances away. Or if you were to talk about our Earth, the largest point, its circumference around the equator, that's about 25,000 miles. So you have to fly around Earth's equator about 4 times to get to the distance of this asteroid. It is very distant, but it's also a lot closer than a lot of things do get. The asteroid that we were talking about just the other week, 2017 BX, that you'd need to fly around Earth's equator about 6.5 times to get to that one. So this one is a bit closer than we've previously been experiencing.
All right. Again, this is 2017 BS. And Eric, I got tons of questions for you, as you you can probably imagine. But first, I have a question for our audience. Here at Slooh, we've been tracking asteroids for years. We've actually named several of them ourselves. And some of the names that you might remember are Spooky, the Halloween asteroid, Moby Dick, Pitbull, the Flea, and of course, Rerun earlier this month. So we want to see what our viewers can come up with for today's asteroid. Please send us your name suggestions on Twitter by tweeting them to @Slooh or by dropping them in the live chat on Facebook. We'll read some of our favorites on the air a bit later on. If you have any questions for Eric, you can use Facebook and Twitter to send them to us as well. All right, so the size of this one, Eric, compared to, say, Rerun?
Oh, yeah. So we're talking about something that's somewhere between, there's a little bit of a range, 36 to 82 feet. And so last time we were talking about Rerun, we were talking about it in terms of the size of a whale, in particular a killer whale. So the Rerun was about somewhere between 13 to 46 feet long. And so that's about, the size of a full-grown killer whale in the middle of those numbers. And so if we were going to talk about a little bit of a larger whale, perhaps a humpback whale might fit for this occasion. Though I don't know how many people in our audience are extremely familiar with the size differences between whales. So a different way to put it might be the height of, say, a 5-story building as opposed to the height of, say, a 2-story building for our previous asteroid. So this one is a bit bigger and a bit closer. So we're hoping it's going to be a little bit easier to see in our live feeds. And so keep looking throughout the night here as we, inside that circle, that's where we're expecting to see that streak, that asteroid. And let's see what we do see as this night goes on.
So Eric, you said between 36 and 82 feet. Those are our best guesses. Why can't we pin it down to a solid number?
So the uncertainty comes in a lot of ways from how new and fresh this object is. It's something that we discovered very, very recently. It was discovered on, I believe, January 30th of this year by the PanSTARRS, the Panoramic Survey Telescope and Rapid Response System. So across, the world, we have a couple of these surveys that are looking for objects like this that are streaking across our sky. And when small objects get close enough, that's when we start to pick them up. And so this very recently, January 30th, now it's going to make its closest approach on February 2nd today. So it had to be really nearby before we actually did spot it. So this is a very new object to our view. And so now we're just starting to observe it. Once it was discovered, different observatories across the world, they would be pointing their telescopes in that direction, trying to get a handle on the orbit of the object, on where it's going, where it's been, and also its size, its light curve, sort of what it's made of, all those different things. We're trying to discover those right now. And because there's a little bit of a dearth of observations, we haven't observed it for too long yet. There's going to be a bit of uncertainty for a lot of things. So our Slooh astronomer, Paul Cox, who's lining up the telescopes to get these live feeds for us of these objects, is having to hop on the latest observations, the latest refinements to the orbits to make sure that we're seeing this object in the telescopes. And so it's very much a work in progress, our understanding of this asteroid. And we know more and more at every point, and this close approach, in particular, when it's closest to us, will be one of the best opportunities for us to learn as much as we can about it before it flies way out in the distance, far, far away from us once again.
And Eric, I'm guessing that we're also not quite sure what shape this thing is. And correct me if I'm wrong, but as it moves in its orbit or in its path, does it tumble?
Tumbles, and so can depend a lot on, the type of asteroid we're looking for. Usually when it comes to small ones, we don't expect them to be as circular, as spherical as we do the larger ones. So the really large objects that we see out there when we talk of things like Ceres, like Vesta, we're seeing things that have something of a planetary-like shape to them, because as the objects get a bit larger, that's when they start to become this sort of gravitationally coherent body, which is it sort of falls into this spherical shape. Whereas when you have the smaller objects, those are ones that are a little bit of dust and cracks and crackers. They're things that haven't really become these snowballs and built up to the size where they start to form that circular shape. So they are a little bit more uneven. You see certain asteroids that maybe look like they were the product of collisions, that they could just be
Mm.
two separate objects that just squished together. So there's a lot more variety in the smaller shapes that you see versus the larger ones. They are on their way to becoming planets, but didn't quite make it just yet.
So again, look inside the red circle, folks, and you will see 2017 BS32, and it needs a name. So please, we're all begging you, it needs a name. Hit us up on Facebook with some names of your choice, or hit us on Twitter at Slooh, and let us know what you think, because it desperately needs a new name. Now, how fast is this thing going, Eric?
This one, okay, so it's going to be about 7.81 miles per second. To put that in easier context, that's about 25,800 miles per hour. And last time when we were talking about 2017 BX, we compared it to a bullet shot out of an AK-47. That one was going about 10 times the speed of a bullet shot out of an AK-47, which is about 1,600 miles per hour. This one is a bit faster. This is 25,800 miles per hour, and it's about 16 times faster than that 1,600 miles per hour number. So yes, this one is speedier than BX-17. It is larger than BX-17, and it is closer than BX-17. That means that, when we look through these live feeds, we're going to probably have a better chance of seeing something flit across our screen. Also, we're seeing this directly when it comes at its close approach, which is happening in just about 14 minutes. So it's at its closest, it's going to be at its brightest. At the same time, though, this is such a small object. I'm wondering, this will totally make sense in just a moment, but Jerry, have you ever been like looking out? Have you been on a boat looking for whales? Have you been whale spotting before? Have you done that?
Oh yeah, tons of times. Yep.
So when you did that, what was the farthest you could look and still see that whale? Like, do you have
Uh,
an estimation on that?
I would say maybe a mile away.
Maybe a mile. So you're spotting this and you're looking with people.
Depending on the spout, the size of the spout.
Okay. So maybe a mile or two might be a good estimation then?
Sure, sure.
Okay, so a mile or two here on Earth, we're looking for a whale-sized object in the ocean. When we're looking at these asteroids out in space, they are also, when we're talking about the small ones, the ones that are getting really close by to us, we're talking about whale-sized objects that are 100,000 miles away from us. And so what we have to do is we have to look really closely with really, really great telescopes. But again, we're looking at this, relatively small object that's floating out in the void of space, just so far away from us. And so that makes it really, really difficult to spot. And so here we need the help of all of you in our community to see what we can see here. Try and see this dim streak of light inside what we believe the red circle will be the position that we're going to be finding this asteroid 2017 BS32. But yes, it's going to be, whale watching to the extreme, I would manage.
Well, I'm looking for the spout. I haven't seen it yet. But that leads to another question, and that deals with asteroid clusters, because as I mentioned at the
Mm.
top of the show, Eric, this is our fourth late-breaking asteroid in 4 weeks. But at the end of last year, we saw almost none. So asteroids do show up in clusters, don't they?
Well, actually, it's a very, very delicate, complex question. And I can sort of talk a little bit about sort of the variables that surround it. But so my initial answer is maybe yes, maybe no. There are a couple things. One being that our surveys are not 100% effective 100% of the time. When they're looking out, they're going to be seeing some other bright objects, say in the sky, those could compete with the survey's effectiveness. If there's a full moon on the night that something's nearing by, they might not see it because that full moon is so bright it could wash out dimmer objects in the sky. Also, we have to think about the season. For example, it's in winter time in the northern hemisphere around here. It could be a bit rainy or cloudy in a lot of areas, and a lot of our surveys are ground-based surveys. And so we could be experiencing, if there's a week of rain over the surveys like the Pan-STARRS or something like that, they're not going to be able to look and try and spot things. And so the atmospheric conditions can make things difficult. Also, in terms of the brightest object in our solar system, the sun, that can make things very difficult too. Because, for example, with the Chelyabinsk meteor, 3 or 4 years back, it was something that we didn't see until it collided with us. And that was because it was coming to us from the direction of the sun. So we don't have as great a coverage when we're
Mhm.
looking toward the sun because it's the moon all on a whole other level. It's so bright that when we look that way, it's very, very hard to spot other objects, particularly flying whales out there at very large distances away from us. And so the effectiveness of our surveys, a lot of that can be a gamble as to what direction that asteroid is coming from. Is it coming from a direction where we can see really well in the sky? Is it going to be coming to us at a point in time when we have clear skies and we can see the object? And so that's a whole thing. So it might not necessarily be clusters, but at the same time, we do definitely see clusters of objects in our solar system. For example, a great one is meteor showers. So meteor showers are that on a really, really tiny scale. Meteoroids themselves, those things floating out in space that become meteors, the shooting stars that we see, these are the things that are around the size of a grain of sand. But they don't occur throughout the whole course of the year. They occur at very particular times, very particular months. And that is because there are clusters of these little grains that we hit at just very particular points in the year. That becomes the Geminids, that becomes the Perseids. And so there are on those scales certain things that we do get those clusters. We get them on larger scales too, because our whole solar system is this immense gravitational interaction of multiple different objects. You can imagine if you just threw hundreds of millions of just pinballs into a large bowl and watch them collide with each other. You would see things that might stick together, break apart, group together, all these very, very chaotic motions that eventually become the solar system as we know it today. And so as we study these things, as we learn more and more about whether there are significant groups and clusters of asteroids coming nearby to us, we get to understand a bit more of the story of how our solar system has developed into what it is today. And that's, I think, a question that is very much on the books, waiting to be answered, waiting to be defined as we continue to discover more and more things nearby to us and can slowly unwrap the story as that knowledge becomes more and more clear. So maybe, maybe not.
Well, that sort of answers my question. Maybe, maybe not. All right, Eric, I believe we have another view. Oh, there it is. Okay,
Oh,
that now you can see. Let me just get my glasses for this one too, because it
yeah.
looks like you can see a streak.
Yes, is that so? There's a streak that actually seems to be going outside the circle itself a little bit. Would that potentially be it? I'm thinking it might be.
And that
Okay,
is
so
it,
yes,
I'm told. And this was provided to us by Paul Cox, Eric.
Paul Cox wrangling that asteroid in. So yes, you see that streak that's it's
Mhm.
faint, but it's very, very long. And it's showing us, yes, this asteroid is moving very, very fast. It's just about 7 minutes till the close approach, and we're seeing it live here from our feeds from the Slooh telescopes. I consider
That's
that a victory.
fantastic. Absolutely. That is marvelous. That is fantastic. What do you think of all this, Erica? Do you get chills?
I mean, I find it really hard to digest in a lot of ways that we sitting here, human beings on this one planet, are looking at this object that is farther away from us than we can really ever a lot of us can really ever hope to travel in our lifetimes, going faster than any of us can ever imagine moving. That these extreme factors of space and our solar system are meeting to show us this one object streaking across our sky, and that we see it in this image and it just looks like a streak, but then with our telescopes on it, we can learn so much about it by continuing to observe just the light coming from this whale-sized asteroid flying through space. It's just, it's amazing how far we as human beings have come with our technology, with our passion for space, and our willingness to continue just looking up. It's amazing to me. What about you, Jerry? What are your thoughts
Yeah,
here?
I find the whole thing utterly fascinating. And I'm a newcomer to this line of work and to this field. Hang on a second. I believe we have. Let's see. Oh, Eric, you're going to like this. We have some name suggestions for the
Yes.
asteroid. Okay. I'm going to need my glasses for this one too. Here's a good one. Let's see. We come up with Rocky McRockface. Uh, there's a Bullet Bill Tango for its close dance with Earth. Siraha, which is the name of John's girlfriend, one of our viewers. It's a bit too close for comfort. And then my favorite so far, Punxsutawney, based on the date.
I gotta say, my favorite's Rocky McRockface. The group of observers that I work with over here in San Francisco, we recently got a new telescope. We've officially named Scopey McScopeface on that realm. You know, Bodie McBoatface should really be honored in a lot of different ways, and I'm happy to see it still live and present on the internet. Thank you, viewers. Thank you.
Rocky McRockface. There you go. Uh, so, so this is a relatively small one, 36 to 82 feet is what we're guessing. What about the
Mhm.
big ones, Eric? Is it safe to assume that the larger the asteroid, the less time it'll take to actually discover it?
Well, so how about this? The first asteroid that we discovered was Ceres. That was in 1801. So, pop quiz to you, Jerry. Out of
Yes.
all the asteroids in the asteroid belt, what percentage do you think it is in terms of size? Is it in the top 50% of asteroids? Is it the top 20% of asteroids? Top 90%?
Uh,
How big do you think it is?
I'm going to say top 20.
It is the largest asteroid.
Oh,
Absolute largest. So the first one we discovered was the largest asteroid because, yes, exactly right. The bigger it is, the easier it is to see. You know, this isn't a whale size. This is more like, I believe it is something like 588 miles across. So this is, you know, a significant body in the asteroid belt. It's also something that does have a more circular shape to it, a spherical shape to it. So yes, when these objects are bigger, that's when they're so much easier to see. So the reason that we keep getting surprised by these small ones is because they're so small and we can only really spot them when they're really, really close by.
now I'm not telling you anything you don't know already, but when there's word of an asteroid and it's coming close to planet Earth, a lot of people come out of the woodwork and they think evil thoughts and they think, well, what's going to happen next? Is this the end of the world? And the truth is that asteroids are hitting our atmosphere all the time, are they not?
Absolutely. And we see most of the times we don't really see very big ones hitting our atmosphere or getting really much of anywhere near us. For example, an asteroid that's 3 miles long, so a really big asteroid, that hits Earth on the average of every 20 million years. So, really, really, really long scales of time do we have to worry about those sorts of large things. And the great thing about us in our modern day is when the bigger they are, the more that we know about them, the more that we know about their orbits, their long-term trajectories, where they are going, where they will be. And so, if there was a very large one that had any sort of chance of hitting us, you know, I think humanity would be right on it. We have some potential, you know, solutions, protections in mind, so we could have enough time, enough advance notice to really be able to protect ourselves with that. The things that we see, you know, colliding with our atmosphere, those can be things like, you know, meteor showers. Those are those bright things, and then we get things that are a little bit bigger than that occasionally, like something that's about, you know, 13 feet long will hit our atmosphere every, you know, 1.3 years. So, you know, every year or so. and have this, bright burst way, way up high in our atmosphere. So a lot of the small ones that do hit Earth on occasion never actually really end up making it to the ground in any sort of significant large sense. So yeah, we're really pretty safe when it comes to these asteroids. We know where most of the big ones are. The smaller ones don't pose too much of a problem. Sometimes we do get surprises that affect us in some respect, like things like the Chelyabinsk meteor that was a little bit while back. That was a huge explosion that, again, the problem with it wasn't that it reached the ground. It was more that there was this shock wave that was sent out that sort of caused some glass windows to explode and people got injuries from that shattered glass. But, it's really, in terms of these asteroids, I don't think we're too bad off. And we're just about a minute away from the close approach of this friendly, distant, it's keeping its distance from us, 2017 BS32. We're just about there, folks.
And again, in case people are just tuning in, how big is it? How fast is it going? And how close will it be in 45 seconds?
All right, so this is a very small asteroid, between 36 and 82 feet. So humpback whale, or the size of a five-story building. It's going about 25,800 miles per hour. This is about 16 times faster than a bullet shot out of an AK-47 at 1,600 miles per hour. It was discovered about on January 30th by the Pan-STARRS, and it's going to make its close approach in a mere seconds today, February 2nd. Here comes 2017 BS32.
Also known by some as Rocky McRockface.
No better name.
And there it is. So now what happens, Eric? Now it makes its way away from Earth, and where does it go?
It goes off on, yes, its orbit away from us, and so it will come by our planet again as it makes its orbit around our solar system. But yes, it will start to get very, very far away from us, and very, very soon it won't start to look as much like that faint streak of light. It won't look like it's dashing across our night sky, because the more distant from us, it doesn't mean that it slows down, but it just will look to move a smaller amount of space relative to the rest of the things in our night sky. But yes, this will come by again in 2018. It'll actually make its close approach to Venus as well in the coming year. So this object crosses the path of a couple of the inner planets, and it's not going to collide with anything. We know its orbit as we've observed it over these couple of days pretty well. And so we know out 50 years in advance where it's going to be. And so now that it's made its close approach, we've shook hands, we've made friends, and we wish it, I guess, the best for its future out there in the solar system.
And is there any way of knowing exactly how many asteroids have come this close or been within reasonable distance of the planet Earth through the years, through the millennia?
Yeah, I think that's something that's a work in progress, our understanding of that. The better that we get at really figuring out where these asteroids are, where they're coming from, how many of them there are of different sizes, the more we're going to start to be able to determine that. I haven't heard, a precise number at this point, but as we've continued to gather more and more evidence, like believe it was last year, we had about 50 asteroids that came closer to us than the moon gets. And so was this all of the asteroids that got this close? Maybe. Did we miss some? Also maybe. So it's very much a work in progress. Like we were talking about earlier, our surveys aren't perfect. Some of them, if it's clouded over, you're not going to potentially see an asteroid come by, but we're still working, and we're getting more and more surveys on our planet Earth, as well as planning them out in space. That'll help with some of the weather issues. We have more and more amateur astronomers out there that are using their telescopes, that are getting on board with helping us try and find these objects. And so it's becoming this team worldwide effort that we're getting better and better at every day. And it's heartening to see that there's all these people surrounding us, really passionate about looking for these objects. And I think we see that in the names that we've gotten here today. Everybody has worked together to name this asteroid, and I think that's just we're making friends with these objects. I think it's a good sign.
And Eric, speaking of friends, how about a shout out to all of our the members of our Slooh community? Because let's face it, without them, a lot of this would not be possible because they're the ones who are observing these asteroids to a large extent.
Absolutely, we have groups in our clubhouse and in the Slooh membership that are looking at these asteroids as a team, observing these objects, refining their orbits, sending their observations to the Minor Planet Center, a large body that works on telling us where these objects are and where they're going. And so, yes, Slooh members themselves are contributing to our understanding of what's nearby to us, what's coming around, and I have to applaud their dedication and their willingness to observe and be a part of this community night after night, because without their efforts, we would be a little bit more in the dark than we currently are.
And again, there is a look at 2017 BS32. Call it Rocky McRockface, call it Punxsutawney, call it what you will, but it's somewhere inside that red circle, Eric.
Yes, it seems like it's been following along with our talking heads a little bit throughout the show today, hanging out with us. I like that, that it's stayed nearby in our images. It's pretty great.
Eric, we can't thank you enough. As always, well done, sir.
Oh, thank you for having me on. It was so great to talk with you. I think that we went to a lot of different places today. That was nice.
We certainly did. Well, thanks to you, Eric, and thanks to all of you watching and sharing your thoughts with us and your potential names for 2017 BS32. Don't forget to join us next week when we live stream the first lunar eclipse of the year. That's on Friday the 10th, starting at 5:30 Eastern Time. And of course, we're gearing up for a number of eclipses in the coming months. On February 26th, it's the Southern Ring of Fire eclipse cutting across parts of South America and Africa. And of course, we're working hard on plans for the transcontinental eclipse in August. We'll be broadcasting the entire thing live from the path of totality. Join us here to follow all these events and more. I'm Jerry Monteur. Thanks for stopping by here on Slooh, Space for Everyone.
Away from our planet. And so, just to give that number some perspective, it's about 0.41 lunar distances away. Or if you were to talk about our Earth, the largest point, its circumference around the equator, that's about 25,000 miles. So you have to fly around Earth's equator about 4 times to get to the distance of this asteroid. It is very distant, but it's also a lot closer than a lot of things do get. The asteroid that we were talking about just the other week, 2017 BX, that you'd need to fly around Earth's equator about 6.5 times. Last time we were talking about rerun, we were talking about it in terms of the size of a whale, in particular a killer whale. So the rerun was about somewhere between 13 to 46 feet long. And so that's about, the size of a full-grown killer whale in the middle of those numbers. And so if we were going to talk about a little bit of a larger whale, perhaps a humpback whale might fit for this occasion. Though I don't know how many people in our audience are extremely familiar with the size differences between whales. So a different way to put it might be the height of, say, a 5-story building as opposed to the height of...
See what our viewers can come up with for today's asteroid. Please send us your name suggestions on Twitter by tweeting them to @Slooh or by dropping them in the live chat on Facebook. We'll read some of our favorites on the air a bit later on. If you have any questions for Eric, you can use Facebook and Twitter to send them to us as well. All right, so the size of this one, Eric, compared to, say, rerun?
Oh, yeah. So we're talking about something that's somewhere between, there's a little bit of a range, 36 to 82 feet. And so let's say a 2-story building for our previous asteroid. So this one is a bit bigger and a bit closer. So we're hoping it's going to be a little bit easier to see in our live feeds. And so keep looking throughout the night here as we inside that circle. That's where we're expecting to see that streak, that asteroid. And let's see what we do see as this night goes on.
So, Eric, you said between 36 and 82 feet. Those are our best guesses. Why can't we pin it down to
To get to that one. So this one is a bit closer than we've previously been experiencing.
All right. Again, this is 2017 BS. And Eric, I got tons of questions for you, as you you can probably imagine. But first, I have a question for our audience. Here at Slooh, we've been tracking asteroids for years. We've actually named several of them ourselves. And some of the names that you might remember are Spooky, the Halloween asteroid, Moby Dick, Pitbull, the Flea, and of course, Rerun earlier this month. So we want to